Hello and welcome back to SIG Mechanics. I'm Edmund. In this video, I'm going to explore a question that I have yet to see any real data or testing done for, yet is still a very valid and commonly asked question, which is how exactly do adjustable triggers affect the internal safety of the P320? And in order to begin documenting this, I'm going to be breaking down this video in a way that will allow anyone to really understand not just the end result, but the mechanics behind the data. And therefore, I will first begin explaining the basic mechanics of how the P320 safety works in normal operation. Then I will test to see whether or not adjusting the triggers pre-travel can either fully or partially remove the internal safety. Essentially, I want to see if we can make the P320 fire or at least be made unsafe by simply over adjusting your adjustable trigger. And perhaps more importantly, if the safety can be compromised, I want to check and document how much and to what degree the safety is removed when incorrectly adjusted. Let's begin. Okay, so over the years, the adjustable trigger for the P320 has become extremely popular, and it seems like anyone who upgrades their trigger has at least at some point considered an adjustable trigger as an option. And realistically, that is for good reason, because when you compare an adjustable trigger's profile to a standard trigger's profile, adjustable triggers in general will exponentially decrease trigger take-up, and depending on how you tune the trigger, take-up can be potentially adjusted to the point of almost non-existence. And not only that, but when these triggers are tuned, they can also greatly improve trigger reset and can also essentially eliminate over travel, which when you add all these things together results in substantially shortened trigger travel, which ultimately means greatly improved performance. However, when you take into consideration the design of the P320 and all of its internal mechanics, it leaves you with the question of whether or not these triggers can inadvertently and negatively affect the operator simply due to how the adjustable trigger is designed to make these enhancements possible via exploiting the trigger's starting position, which you will see in a minute is the reason why so many people asked the question to begin with, because the P320's mechanics heavily rely on the trigger's position to either hold or remove the striker safety at any given time. And that being said, I'm going to now provide subscribers with a quick general overview of the P320 safety mechanics before we move on to some real-time testing and data recording. The general mechanics of the P320 safety works like this. When you pull the trigger bar moves forward and does two things. One is engage the sear and pull it down far enough to make the ledge formed on the sear drop low enough to release the striker. And the other is to engage the safety lever. And as the operator pulls the trigger, the safety lever rises up and eventually engages the striker's safety lock lever. Once the lock lever is moved high enough, the P320 striker is free to move into the breech face once the trigger is pulled back far enough. The lock lever itself is this tab of metal that, when the trigger is not being pulled, will physically prevent the striker from entering the breech face, and this is there for drop safety as well as to prevent outside forces from moving the sear without the trigger being pulled, or even if there is a critical failure of the striker body itself, this will help prevent the striker moving into the breech face. Now, it's important to understand that the lock lever can only be moved if the operator pulls the trigger so that the trigger bar can engage it. Now, when you install a fully adjustable trigger and then tune that trigger, the adjustment screw will push itself off the FCU frame, at which point you are essentially causing the trigger to replicate being pulled. The screw then prevents the trigger from returning forward, which gives the operator that feeling of the take-up no longer being there. But in reality, what's happening is the trigger take-up has been physically removed for you as if your finger pulled that trigger. Now, as we discussed, the striker safety is directly impacted by the position of the trigger bar, and therefore it is possible that when you tune the trigger and remove that take-up, you're also starting to engage the striker safety lock lever and remove safety in the process. Now, I will point out that when the FCU is not in the grip, you can turn the set screw all the way to the point of break. Here I have the FCU put to the slide with no grip, of course, and I'm just going to wrap the slide and proceed to turn the pre-travel set screw with the Allen key as far as I can make it go. And eventually I can make the striker release. But I want to be clear here, because what I just did is not really possible when the FCU is inside the grip, because when the P320 is all put together, there is a minimum and maximum you can adjust the set screws so that the P320 still remains operational. Because if you over tune the trigger to the degree I just did here, if you try to use the pistol now, you will not be able to either pull the trigger to brake, or even if you could, you would not be able to reset the trigger after the brake. So again, just to clarify, although completely pulling the trigger to brake is possible with the pre-travel adjustment screw, the reality is it will be extremely unlikely that you would ever be able to actually use the P320 in this condition. That being said, one of the things I want to make sure to do when we start testing and tuning the trigger is to adjust the trigger to the point where the P320 is able to work, but also is tuned to the point where the take-up is almost, but maybe not entirely gone, which is what most people will do, of course, when they buy the trigger in order to get the expected performance that the triggers are known for. So going forward, when I'm testing the tuned trigger to verify whether or not it's disengaging safety, I will make sure that the trigger will brake and reset on every trigger pull and after I rack the slide each time. Now, a quick disclaimer, in this video I am using the Armory Craft flat adjustable trigger. However, I want to clarify that the testing you're about to see is representative of any of the pre-travel adjustment triggers on the market, and the only reason I'm using the Armory Craft trigger in this video is simply because it's one of the more popular fully adjustable trigger models at the time this video was made. I should also add that most fully adjustable trigger manufacturers will recommend that you do not completely eliminate take-up, especially if the trigger is for carry purposes, in which case it would be best to not adjust pre-travel at all. And therefore, subscribers should note that adjustments to triggers pre-travel should only be done to competition P320s only per manufacturer recommendations. I also want to mention that for those that might be wondering about this, I will not be including adjustable triggers that only adjust for over travel in these tests, because post-travel adjustment triggers simply aren't candidates for potential internal safety disengagements, since they don't have any effect or they don't modify any of the mechanics related to the P320 safety. Okay, so let's take a look at the testing setup. For the setup, as you've seen previously, here I have the slide and the FCU coupled together without the grip. And as you can see, because the slide still has the barrel, the recoil assembly, and the takedown lever in place, if we look at the rear of the slide, the FCU is naturally aligned to the slide like in normal operation. Now for the test, what I'm going to do is mount this P320 assembly to a vise to keep it in view as I'm working. And so now if I zoom in, you can see the mechanical function of the P320 very clearly. So the trigger bar is right over here and it sits just behind the striker's leg here. And right next to it is the safety lever, which is also situated just in front of the trigger bar. And so if I pull the trigger, you can see the trigger bar moves forward and interacts with both the sear and the safety lever almost instantly after moving it. So if I pull the trigger further, the striker releases, and now I can even hold down the trigger while racking the slide, and we can actually see the reset of the trigger bar as well. So here is the trigger bar and below it is the sear's leg. And if I just ease off the trigger bar falls and resets behind the sear's leg again. And I'm showing you this so that you can see that the assembly is truly a fully functional setup. And so you know that the results of the upcoming test is related to the actual and true mechanical assembly. And that the only thing really we're missing is the grip. Now I want to draw your attention to the bottom right of this assembly, and I hope it's clear on the camera, but this metal piece right over here is the striker lock lever. And this right above it, as you can see I'm moving it back and forth, is the safety lever. Now watch as I pull the trigger. The trigger bar begins to move the safety, and if I keep pulling the trigger, it further pushes up on the lock lever. And then inside the P320, the safety is being removed so that once I pull the trigger far back enough, we hear the striker release. Okay, so let's start documenting this test. So the first thing I want to do is establish the baseline resting position of the striker safety lock lever when the P320 is configured like a factory model. So the set screws are in no way affecting the trigger positioning. And before I start, I also want to quickly note the gap between the trigger bar and the sear right over here so that you can compare this after we tune the trigger. Now, the way I'm going to document the resting position of the safety is by using this carbide tip scriber to physically and permanently scratch the metal surface of the lock lever right where the lock lever becomes visible off the body of the slide right over here. Okay, so once again, this line now represents the safety in its normal resting position before the trigger is even touched or tuned. Next, I want to document the tuned trigger position. And to do that, I'm going to make adjustments to the trigger using the Allen key so that we can properly replicate what the average person will do when they install this type of trigger, which is to attempt to remove almost all the take-up. Now, the problem when tuning a trigger is that it's going to be virtually impossible for you to know exactly how you are affecting the internal safety when you're turning the set screw, unless you have some sort of extremely accurate testing equipment like this trigger scan device over here, which would help you verify what you did. So on average, most people will do some trial and error testing to tune the screw until they have just enough pre-travel to allow the trigger to work, because as I mentioned previously, if you over adjust the set screw, you could potentially make it so that the trigger might release the striker, but then won't reset properly, or you simply get a dead trigger. So generally when installing these triggers, you need to do some trial and error to get it to the sweet spot, where the trigger works consistently, but also has the shortest trigger travel. And so I'm going to tune this trigger now to that level and document the tuned position of the safety. Okay, so here we have the tuned trigger, and as you can see, when I pull the trigger, the striker releases, and when I rack the slide while holding down the trigger will also reset. And at a glance, you can also see that there's very little pre-travel at this point. And if we look at the internals of the FCU, you can see that the trigger bar and the sear are pretty much in contact with one another, with maybe just a fraction of a gap between them. Whereas if you recall from before, when we looked at the internals, there used to be much more of a gap over here. And so now that we know the trigger works, I'm going to use my carbide scribe to mark the lock lever once again. And so this line is now representative of the position of the lock lever when the trigger is tuned and the P320 is still fully functional. Now, also as a reference, we need to document at what distance the lock lever travels to when the P320 actually discharges, because by the time you pull your trigger enough to discharge, the safety lever will not have only removed all the safety from the lock lever, but it would have continued to raise the lock lever way past the height needed to disengage it. Because essentially the lock lever and the safety lever will continue to move up until the trigger hits the trigger stop pin on the FCU. And I'm doing this so that you can see where the lock lever ends up moving to at the exact point during a trigger pull. So with the P320 reset, I'm going to begin turning the set screw continuously and stop at the exact distance the trigger travels to the instant the striker releases. So there's the striker releasing, and now I'm just going to use the carbide scribe to mark the lock lever again and note the distance it moved at the time of break. All right, so the last thing we need to do is verify the exact distance the lock lever needs to move in order to reach what I call the safety delete point, which is the absolute minimum distance the lock lever on the striker housing needs to move so that it can no longer physically prevent the striker from moving into the breech face. And to do that, I'm simply going to use the same setup we already had for the testing, except now I have removed the main spring and the reset spring from inside the striker housing, but I have left the lock lever spring in place so that the only thing preventing the striker from falling into the breech face is the lock lever tab itself. Now in this setup, I'm also going to be mounting the slide assembly vertically so that when the safety lever has pushed the lock lever sufficiently to disengage striker safety, the striker will fall by gravity. And as you can see, I've also removed the barrel from the P320, and I did this in order to allow you to see and verify that the striker has moved its way into the breech face in the next test. And so now I will turn the set screw with the Allen key until the striker free falls into the breech face, and the set screw thread is what's going to give us an extremely controlled way of pulling the trigger so that we can have an accurate end result. And I hope the microphone caught that noise. That was the striker falling. Let's just take a look at the breech face now. And here you can see the striker is protruding into it. And so now I will mark the lock lever for the last time with the carbide scribe and note the distance that the lock lever moves to at the point the safety has been entirely removed. Okay, so now we have all the information we need to form a proper conclusion. We capture the starting or resting point of the lock lever, and we can call that the minimum distance of travel. We capture the distance the lock lever moves to at break, and we can call that the maximum distance of travel. We capture the distance the lock lever travels to when the trigger is tuned, and we can call that our adjusted distance of travel. And last, we capture the distance the lock lever needs to move to in order for the safety to be removed, and we can call that the safety delete point. And so now with that context, here you can clearly see that the safety was greatly impacted by the fact that the trigger was adjusted. But I'm not just going to stop here, because I want to quantify this further by measuring these distances to come up with a percentage of safety lost when the adjustable trigger is installed and tuned. So to start, we need to measure the notches made on the lock lever, and to do that I will use my calipers here. And so between the minimum and maximum distance of travel, we have a total of approximately 0.08 inches. And now between the minimum distance of travel and the adjusted distance of travel, we get something approximate to 0.03 inches. Now let's get the measurement between the minimum distance of travel to the safety delete point, which seems to be around 0.06 inches. Okay, so let's take these numbers and calculate the percentage of safety lost when tuning a trigger. Okay, so here is the lock lever once again, and from the minimum to max we determined is 0.08 inches, but that's just a reference. The important numbers are actually these. The minimum distance of travel, or the resting point, which we are saying is 0.00 inches, the distance from the minimum to the safety delete, which was 0.06 inches, and the distance from the minimum to the adjusted distance of travel, which was 0.03 inches. And therefore the amount of safety removed is equal to 0.03 divided by 0.06, which is 0.05 inches, meaning that once the trigger is adjusted, you are losing approximately 50% of the internal striker safety, and that's assuming you don't overtune the trigger in a way that allows the safety to be further reduced. Now, in order to further drive my point home, as well as provide subscribers with further evidence of what I've just shown you, I've gone ahead and 3D printed this OEM slide that, as you can see, I've made a couple modifications to the print in order to enhance your visibility. To begin with, I did remove the extractor spring at the back here because we just don't need it for this. And I also chopped off the front end of the slide. And really that had more to do with the limitations of my 3D printer size more than anything else. And last, as you can see, I made a large window on the side of the slide here. And this gives us a complete and unobstructed view of the striker and the internal safety mechanisms inside. And so now I can take a complete FCU assembly and mount it to the slide. Like that. And of course, the striker is not engaged to the sear yet, so it is loose. But if I rack the slide, you can see that the striker mainspring here is now compressed all the way back. But because of that, I also need to manually hold down the slide in the FCU so it won't spring forward on us, and this all remains in battery as I work. And so now that I have this assembled, I do want to show you a few things here. First, I want to point out that the set screw is not engaged to the FCU body. So the trigger is in no way engaged at this time. And second, I want to point out that there is a very small, almost insignificant distance between the lock lever and the safety lever. And I'm just going to zoom you in a bit here, and hopefully you can see what I'm talking about on camera here. But the two parts are almost but not really touching at this point. So again, the trigger is not engaged, and this is currently the distance between the two parts. And now if we look underneath the FCU, we can see the gap between the trigger bar and the sear. And so here is where things get interesting and potentially dangerous. And to show you what I mean, I'm going to start turning the set screw until we can physically see the lock tab begin to rise. So right there, the set screw made contact with the FCU frame, which means any further turns will now start to engage the trigger itself. And so we just want to keep turning this until we get the safety lever to make contact with the lock lever right there. So that was about a half turn of the Allen key, and we already made contact with the striker lock lever, but we haven't started to disengage it yet. So let's do that now, and I'm going to keep turning the Allen key. And right there with maybe about a quarter turn or less of the Allen key, you can see that the lock lever was engaged. And so we've ever so slightly moved it upward, which means that we have already began to remove the internal safety off the striker. So let's take a quick look under the FCU now. And right there, you can see that even though we're just beginning to disengage the safety, we're not even close to completing that gap between the trigger bar and the sear. Because if you recall, most people, when they tune the trigger, they do it to the point where there's barely even a gap between the trigger bar and the sear. So let's complete the tuning process so that the trigger bar just barely meets the sear edge. Right about there. And so now I want to bring your attention to this window over here on the striker's housing, where we can actually see that the lever is significantly raised up. And right there, what we're looking at now is that give or take 50% loss of internal safety on this P320. Now, of course, it's hard to tell just by looking at this all stationary here. So as a reference, I'm just going to show you the action by rocking the FCU back and forth so the safety lever will engage and disengage the lock tab while the set screw holds down the trigger position. And you have to understand that this small tab of metal here is only approximately 0.03 inches thick. So it's not much surface area to start with, but clearly you can see that by this point, whatever protection that tab on the lock lever provided you is pretty much gone. And also remember that by the time the P320 discharges, that tab has already been completely removed out of the way. So the danger here comes from two things. If the striker hook were to fail right now, that striker has almost no physical block at this time. But also by removing that much internal safety, you've seen that we've basically pulled the trigger a significant distance. And as anyone in this community knows and hopefully understands, one of the most important rules of firearm safety is to never put your finger on the trigger unless you're ready to discharge. And that includes just resting your finger on top of it. But in this case, you've gone beyond that because this is the equivalent of not just resting your finger on the trigger. You've essentially been walking around with the trigger permanently pressed and mechanically, permanently, and actively disengaging the safety, which is something I urge subscribers to consider strongly when you are tuning your P320. Now, I do want to make clear that at this point, if you haven't tuned the trigger to the point where the sear is starting to move, like we did here, where the trigger bar is only just behind the sear leg, but not pushing on it yet, you haven't technically began the process of firing the P320. Now, if it's possible to have the trigger tuned to the point where the sear is even slightly being engaged, but still remains operational, that's not something that I have tested for here, but I can presume that it is plausible based on what I've seen here and based on the fact that the trigger tuning is not a science where the average person would know the absolute distance that they've made that trigger travel while they were tuning the gun. However, again, this isn't something I've tested for, and I don't want to make claims without any of the data on hand. So as far as what I do know for sure, the internal safety is being compromised, but I do not know yet if the sear has also been compromised as well. So in conclusion, there is no doubt that the current design of fully adjustable triggers, specifically those with pre-travel adjustments, will in fact at least partially disengage your P320's internal safety should you unintentionally tune the trigger too much. Now, the problem is that too much is fairly subjective. From what I can tell, any adjustment that can in some way affect the distance of trigger travel, no matter how slight, is going to start the process of safety deletion. So within the community of firearms and firearm safety, even a 1% loss of internal safety could be considered to be a hugely debatable compromise for some people. Now, I will note that adjustable triggers have been used in P320s for quite some time, and no one has ever really pinpointed that a tuned trigger has been the cause of things like the negligent discharges. But the results here do paint a picture that even if they're not directly responsible, they definitely have potential to play a part in some of those issues. Now, the good news is that if you're after a particular look, or if you just like the ergonomics of any particular adjustable trigger, you can still use the triggers. But from the point of safety, you will want to retract the set screw and make sure to include pre-travel in the overall trigger travel. Now, if you've been following the channel for some time, you know, of course, that I like to design and create and overall just find solutions to problems. And since I discovered this finding a couple months back, I have been working on a potential solution to the problem, which although is promising, I'm still testing heavily before I share it with the community. But basically, it will allow you to continue to use the adjustable trigger of your choice, but also remedy the safety loss issue I found here. So stay tuned for that. All right, so I want to quickly thank Desert Depot Arms for sponsoring this video. You may have heard of them. They are a master dealer for Sig Sauer. So if you're looking for parts and components for your build, they are a great source and you should definitely check them out. Of course, a special thanks to all of you as well who continue to support the channel either by subscription or engaging with me in the comment section, as well as liking these videos or even sharing these videos with other people in the Sig Sauer community, which is helping to keep this channel growing while educating others about their firearms. Okay, that's all I have for you today. See you soon.